Hello students, today we will be doing more numericals on projectile, and in this case we have taken one of the question. Look at the question what is given. A particle is projected at 60 degree to the horizontal with a kinetic energy K. The kinetic energy at the highest point is what? We simply means there is a particle and the particle is imparted with the angle of projection is 60 degree, and we need to find out the kinetic energy at the highest point. We need to calculate the kinetic energy at the highest point. That is what the question is given. Okay, now we all know that when it's given the horizontal at 60 degree to the horizontal. So here we will take the kinetic energy. The basic formula for kinetic energy is what? K is equals to what? We generally write half mv square, that is the speed square. I'll write speed square. Okay, so here what we find at here the along the x directions we have got the component. If you remember, we have done the case of the projectile. This is what we have. This is the initial velocity u making an angle theta. This is u cos theta along the horizontal, and this is u sin theta. Okay, this is the general figure that we have for the projectile. So here the component, that is the component along the x direction, is ux is equals to u cos theta. So at the highest point k will be equals to, k is equals to half m, and instead of speed square we are going to write u cos theta ka whole square. So what we are getting up? We are getting half m u square cos square theta. So theta is what? 60 degree. So this is half m u square cos square 60 degree, and cos square 60 degree is half. So we get this value as equals to we are getting this value as equals to, this is what we got, k. So this is k, and this is half square, so it becomes 1 by 4. So this is the change. Let us write the change, and this is the initial k. This is the initial k. So this is the initial k. So what you find at here, you can find that the final k is getting reduced by the initial by 4 times. It is k dash is equals to k by 4, or the initial is more and the final is less. So we have got this condition that at the highest point. Now we will just look at the another question. Look at another question. A particle of mass m is projected with velocity v making an angle. Look at the question. A particle of mass m is projected with velocity v making an angle 45 degree with the horizontal. When the particle lands at the level ground, the magnitude of the change in momentum is what? So I repeat the question. A particle of mass m is projected with a velocity v making an angle 45 degree with the horizontal. When the particle is landing over the level ground, the magnitude of the change in its momentum is what? It means what? We need to find out the change in momentum when it is landing. So we all know that when the word change has been given, for the horizontal part there is no change. So since we know that the horizontal momentum does not change, we have the condition the horizontal momentum does not change. So if it is not changing, does not change, so it will be the vertical one which is going to change. The vertical one is changing, and we know that the vertical one is given by u sin theta, right? So here, because we have seen in the earlier question, this is u sin theta. So what is the formula which will be taking up? We will have this as the change in momentum. Change in momentum is equals to mv sin theta minus, and this is minus mv sin theta. So this becomes twice of mv sin theta, right? So this becomes twice of mv sin theta. Mv sin theta minus of minus mv sin theta, so it becomes twice of mv sin theta. Now the angle of projection is 45 degree, so substitute 45 degree in this case, 45 degree. So this becomes equal to what we are getting up to mv 1 by root 2. Sin 45 degrees 1 by root 2. So finally we are getting the change in momentum as equals to root 2 mv. It's very simple. It's very simple, but then again, if you don't know the concept, it becomes difficult. So you try to understand what we have to vary and what we need to keep constant. So make sure that the figure or the angle of projection, everything should be very clear for you. Where is the angle given theta? So all these things matters when you solve such questions. The next question that we have here, look at the question here. We have a question, a projectile is given an initial velocity of, look at the vector form, I caret plus 2j meter per second. That is the initial velocity given to the projectile. And when I caret is along the ground and j caret is along the vertical axis, okay. Given the value of g as equals to minus 10 meter per second square, what will be the equation of the trajectory? We need to find out the equation of the trajectory. That becomes very important. And since we are doing with the equation of the trajectory, we will be using the formula for the trajectory. What is the formula for the trajectory? The solution, let us start. The formula for the equation for the trajectory is y is equals to tan theta, x tan theta, sorry, it is x tan theta minus gx square divided by 2u square cos square theta. So what, this is the formula we have, y is equals to x tan theta minus gx square divided by 2u square cos square theta. Now we can very well take this 1 by cos square theta up as sec square theta, and then the sec square theta is 1 plus tan square theta. So we will be using this whole through. So let's write this equals to x tan theta minus gx square by 2u square, and this becomes sec square theta. Now sec square theta is 1 plus tan theta, so tan square theta. So y is equals to x tan theta, we have minus gx square by 2u square, and instead of sec square theta, what we are substituting? 1 plus tan square theta. So we have got this formula. Now look back to the question. The initial velocity is I caret plus 2j caret. Initial velocity we are finding for u. Initial velocity is I caret plus 2j caret, right? So what will be the magnitude of u? Magnitude of u will be 1 square plus 2 square, isn't it? So this becomes equals to root over 5 meter per second. That is the value of u we are taken up. Okay, so we have got the value of initial velocity because it was in the vector form, and we have taken up the magnitude. Now next we need to find out theta, because we are having tan theta in our equation, then only we can get some equations. So let us try for tan theta. Let us try tan theta. For in order to get the value of tan theta, we have the j component, the component of j, and then we have got I caret ka component of I caret. Okay, now the same equation, this will be 2 divided by 1. So this will be 2 divided by 1. So it simply gives an idea that tan theta is equals to 2. So we have got two very important values here. We got the value of u as root 5 and the value of tan theta as equals to 2. Now we are going to substitute the entire things in this equation. The value of g is already specified, that is minus 10 is already given. So we are going to use the complete equation to get the values. So let us substitute everything in this and let's see what we are getting up. And in order to use this, we are taking up the condition u is g is not minus, sorry, g is 10, it cannot be minus. Let's g should be 10. Okay, let's write y is equals to x tan theta minus, I'm writing the formula, and then we will substitute 1 plus tan square theta, right? So let us substitute. We'll keep x as it is, y is equals to x. Instead of tan theta we are going to write 2. Okay, minus g we have taken 10, x square will remain as it is, divided by 2 root 5 ka whole square. This is 1 plus tan theta is what? 2 square. So this is equals to 2x 2 5, and this is root 5 is 5 gone, so it is minus x square, and this is 1 plus 4 5, so it is 5. So we get the equation, the trajectory is 2x minus 5x square. This shows that it is the equation of a parabola. This shows that this is the equation of the parabola. Okay, so this is how you can do the trajectory. What we got, let me repeat the question. We had the equation with a given initial velocity in the vector form, and we were not having an angle, so we first have taken the general formula: y is equals to x tan theta minus gx square by 2u square cos square theta. 1 by cos square theta, we took the sec square theta, then we got the value of sec square theta as 1 plus tan square theta. So the entire equation got transformed into tan theta value. Then we got the value of the magnitude of the initial velocity by the method we generally use, the root over of 1 square plus 2 square. We got this as root 5, and then we tried to get the value of tan theta. So we got the value of tan theta as 2, and after getting all the values, we are substituting everything in the final equation that we generally have, the equation of a parabola. And we get this as equation 2x minus 5x square, and this shows that this is the equation of a parabola. So this is how you do. Thank you for watching. Hope you are understanding the projectiles.